My name is Alessandro Cuttin. I am a PhD student at the University of Trieste, and in the meanwhile I'm running a spin-off company in the aerospace field, specifically in the Cubesat field. So, how many of you are familiar with the Cubesat 10 by 10 by 10 centimeters, and it cannot weigh more than 1.33 kilos. It was originally defined in the Cubesat standard specification, authored by the Polytechnic of California, and it is considered to be modular. So there can be Cubesats the size of 1U, 1.5, 2, 3, and so on. The original specification envisioned from 1 to 3 units. Then an extended version enlarged the size of the Cubesat up to 16 and 27 units. So, but okay, this is another form factor for a spacecraft. What's the key point about the Cubesat? It is deployed by a Pico satellite orbital deployer. So, let's see. Let's skip at 1.10. Okay. So basically, the spacecraft during the launch is completely contained in a orbital deployer, which is an enclosed container that has a spring in it, and so when the moment is reached, one of the doors open. The door of the people opens, and the spacecraft comes out. This can be done on any type of launcher. You have seen in the previous video it was from a rocket, but it can also be launched from the International Space Station, thanks to the availability of the Kibo module. So here comes another one from another perspective. So it can be launched from any transporting means in space, the International Space Station, American launchers, Indian launchers, and so on. Also European launchers. So, and this jack-in-the-box concept is what like the most launch providers, because the satellite is entirely shut down during the launch operations. And also was liked by the Cubesat developers. And in all these years, we have seen a huge technological improvement. And I want to provide some examples. This first example is about the attitude and determination control subsystem. We started from a sort of controlled and uncontrolled attitude system, because first the Cubesats carried a permanent magnet in them, and so the team that launched that Cubesats knew that it wasn't about to spin randomly, but it was about to spin around the Earth magnetic field. So this is a passive system, you have no control on it, and so on. But years passed, and nowadays we have a fully controllable ADCS that with gyros, with magnetotorquers, and so on, that enables a pointing precision of 0.5 degrees, which is not that much because we can see better decisions, but for a Cubesat it is really a huge step forward. Then we have communications improvements. We started from simple dipoles antennas operating at VHF and UHF radio amateur frequencies, and now we have more complex communication systems, more complex antennas. On this spacecraft only you can see a small array of patches and also a reflector array, which is a very demanding antenna in terms of design. But it also provides very, very high gain, pointing capabilities, and so on. And the last example is propulsion. At the beginning, no propulsion was provided in Cubesat, and also the Cubesat design specification forbid them. And now recently we have electric propulsion, so something that can be stored inside a Cubesat because it needs a small volume, and something that can be operated safely because an electric propulsion system does not require pressurized vessels and so on, and is also efficient in the way that it can operate for a long period of time. So the spacecraft can reach higher velocities with the same amount of volume taken by the system. And another very great benefit of Cubesats is that they can be produced, manufactured in a sort of mass production. You can see here 20, 30 pieces of the same spacecraft. So, what are the purposes of Cubesat? Why they obtained the interest of the space community? Because they started as educational tools to provide students hands-on experience and so on, but they also obtained the interest of emerging nations, countries that wanted to establish their presence in space. And this Cubesat is the first satellite launched in low Earth orbit by the Ecuadorian Civil Space Agency. Also, educational purposes, but they gained the agency's attention because they are useful for in-orbit demonstration purposes. You have here 3 examples of the European Space Agency Technology Demonstration Campaign. The first is a satellite for the study of heat shields. So the first satellite will re-enter in the atmosphere, and the heat that data will be sent back to Earth about the heat shield. Then we have scientific. The one in the middle is Picasso. That is. And will carry scientific experiments, and also will test the first laser communication between Earth and space. And then we have this is GomSpace, GomX3, and it was intended to collect data from the ADS system. and I will talk about this later. And then Cubesat provided innovation in the space services. So there are companies like Planet Labs, like Spire, that used this concept of Cubesats, so spacecraft that can be launched from any launcher, that are really easy to develop, that can be replaced at a faster rate than conventional satellites, to provide a constant monitoring of the Earth. So, for example, Planet is in the Earth imaging market, and it does not provide pictures with high resolution, but it provides highly pictures with daily updates. So you can see how a piece of surface of the Earth changes within 24 hours. Or Spire wants to collect and redistribute what we used to call signals of opportunity. So radio signals that are conceived for to be received from ground receiving station, but that can also be received from space. So just to give an example, ADS is a system that is carried by vessels in the maritime service if the ship has more than 300 tons. And it has this system that beacons its position and route every minute, let's say. But the moment after the ship goes beyond the horizon, the ground stations are no more capable to receive these beacons. But they can be received from space, so all the maritime traffic can be tracked from space. And what's next? So this is what the community the space community have achieved, but there are interesting developments. Next developments are mega constellations. So a huge number of nanosatellites that are sent in orbit to form a group of almost coordinated satellites that can be deployed in swarms, or they can be deployed in planet orbits. But numbers will get very large. We talk about 100, 500 nanosatellites. Then we have coordination in flight. So there are experimental launches to test rendezvous between the two spacecraft. And when you have the capability to make a rendezvous, you can let's say provide some debris removal capability. Someone may think, but if you develop the technology needed to do rendezvous, you can have a coordinated flight of several nanosatellites, and you, as an example, can take a stereoscopic image of the same place, and with stereoscopic images you can obtain 3D view. And then we have lunar CubeSats, CubeSats for Mars, and to some extent, okay, I'm finished, I'm done. And to some extent, interplanetary exploration with CubeSats. And this is done mainly by using these nanosatellites as daughter satellites of bigger spacecraft. So once a bigger spacecraft reaches the Mars orbit, then one or more nanosatellites are deployed and can provide auxiliary functions. So this is what's next in the coming years. Thank you. Question. You have a question?
First one. Just one.
Come on. I will answer fast.
So which are the payload that that can be on board a Cubesat? Yes. Then.
You can have as long as you can shrink your payload, you can fit it into a Cubesat. But as I said, 6U, 27 units Cubesats starts to be designed, so larger payloads can be fitted into them. The size of a shoebox, let's say. But you can fit in scientific. Scientific is a very broad concept. But,
so for the example we did, we spoke about IS antenna and then internet, so radio frequency. Well,
yes.
Yeah, then
yes.
Stereo.
But Earth imaging.
Yeah, but optic one, kind of.
What kind of optics you can fit in? I'm not an expert in optics, but as the longest optics is about 20 to 25 centimeters, I guess.
I mean, my question was to use stereoscopic image, you use an optic. Correct?
I was just making an example. So.
Okay.
Other question? Come on.
A constellation of Cubesat, could it be considered as a space junk, or do they have a lot of? How long do they stay there?
This is the most common question, and if you and Cubesats, as any other spacecraft, must comply with the regulation of re-entry within a 25 years time span. But of course, there is a common acknowledgement that this time span is too long. Mainly, many missions can be designed to stay on orbit for 3 to 6 months just by choosing the appropriate orbit. And otherwise, if you are a company like Planet Labs, let's say, and you want your satellite to stay in orbit for at least 1 year, and also you can plan. You can design the orbit so which launcher you want to use, because the launcher then puts you in a certain orbit. But there are also active systems for satellite removal, for satellite decommissioning are being developed nowadays. Last one? The same question. Okay.
Yeah, we have no time, sorry.
Okay.